Guys, this is really exciting. If you follow the 3D Gaussian Splatting space, you've probably come across a guy named Michael Rubloff. He's the founder and managing director of radiancefields.com, one of the earliest and most consistent sources that's been tracking this technology. And for this interview, I prepared a set of questions that come straight from the things that we think about every day. And I was genuinely curious to hear his take. So let's get into it. Man, it's been a long time.
I'm trying to think about when the last time I saw you, at least in person, was. And I feel like it may have been GTC 2024.
It was the only time we saw each other in person, I think.
I think so.
Could you tell the audience who don't know about you, about what you're doing and who you are and stuff?
Definitely, yeah. So my name is Michael Rubloff. I am the founder and managing editor of a website called radiancefields.com, whose purpose is to really centralize all the information surrounding the world of the different radiance field representations, which include Gaussian Splatting, whose full name is Gaussian Splatting for real-time radiance field rendering, as well as NERFs, voxel-based implementations, ray trace-based implementations, basically anything that creates really lifelike 3D from 2D images and tries to make it a bit more manageable to go into this world. And so I've been working on the website for coming up on 3 years. So I've been trying to, contribute the best way that I can to this community.
From your point of view, how do you see the transition from traditional geometry to radiance field-based representations?
The traditional geometry approach has been such a fundamental part of the graphics pipeline and has been one that, would take an extreme amount of effort. So it's exciting to me that there's even I've been encountering a growing number of engineers who are starting to say, there's a lot of really tremendous advantages to working with both from Gaussian splatting and the more explicit representation, and even taking a little bit of a longer approach as well and looking at NERF as well as a potential return to. It's really exciting to see even begin to emerge as a conversation. And I actually do feel that it is deserved in a lot of ways to have this be a general conversation to say we have this technology that's very compelling and able to render on a very wide variety of devices. So I think that it's going to be a more of a conversation in the next couple of years too, as people start to realize. And I think it is beginning now, where I've been seeing a growing trend in the last few weeks of people taking their Unreal scenes or their Unity scenes and placing a ton of synthetic cameras inside of them and then turning them just into Gaussian Splat instead, so that they are able to render them across a variety of devices in a more lightweight capacity.
They're kind of embedding in the mesh representation just to turn the mesh to the Gaussian Splatting to adapt the new era.
And KIRI Engine does a lot of work too in this to be able to create really great mesh reconstruction as well, better surface reconstruction from the Gaussian splatting. But I have seen over the last few weeks that somewhat of the opposite happening, where people are taking traditional 3D models, turning them into splats, and it seems like it creates a nice distribution method for
That's
people.
Cool. Actually, a little bit of fun story about, because we were one of the first that turned Gaussian splatting to mesh. But actually, when Chris, my co-founder, he showed me this algorithm to turn Gaussian splatting mesh, I was super opposed to it, because what's the point, right? to turn a Gaussian splatting to mesh, you lost all the advantages. But actually, the one that got me was, because we've been posting a lot of Gaussian splatting related videos on YouTube, right? And a lot of comments were hey, that looks so cool, how do we use it? And if people have some knowledge about 3D modeling, they know that they need a mesh to actually work on their pipeline. But 3D Gaussian splatting, there's no way they can use it. So, because there's so many people asking about, hey, can we convert Gaussian splatting mesh? That's pretty much the solely reason why we wanted to bring this technology to the world. If it's just for me, I wouldn't really make it happen. But because there's market demand, so we put it to the world. So people, if they want the mesh, they can have it. But then, surprisingly, it got really popular.
It's such a large, and well-developed community of 3D modelers, and there's so much can be empowered from this that, it's exciting to see people really wanting to use it as a way to go back into their work. But I think in the end, too, it's just going to radically increase the amount of people who are thinking and creating in 3D.
In your opinion, what was the real turning point that allowed 3DGS to move from research to actual production use?
I think that it checked enough boxes for a lot of people. NERF was not at real-time rates. You can now render NERFs well above real-time. But right out of the box, you were getting Gaussian splatting rendering at 150 frames a second across a very wide variety of devices, because Gaussian splatting just uses rasterization as well.
Yep.
It had a lot of upfront advantages to just be, or there wasn't as much custom development that would need to be done to actually go and support this across a variety of devices and mediums. And given simultaneously a lot of the other work that's being done in like the computer vision and artificial intelligence world too, I think that also helped empower a lot of these changes to move a bit faster than maybe otherwise people would have. I also think too that because cameras are so ubiquitous now in our lives, and because Gaussian splatting just requires a camera of any kind, it doesn't matter if you are using like a really high-end camera or a phone or a 360 camera, you know, you're able to actually go and create content with all of this. And so I think that the barrier to entry just was made so low. And there's also been a great open source community within this world where you have platforms like Gsplat from Nerf Studio back then, which really helped push things forward and get things, you know, a bit more centralized.
Totally agree. That's we aligned to this. When we saw Nerf, you know, of course we were excited, but we were not that excited because it's not real-time rendering. So we just didn't get a point of rendering a video from another video and just to make it worse. Until we saw the Gaussian splatting from the 3PR that year, it was really kind enough for them to share the code with everyone. So you can actually grab the code and test yourself. And that's actually how we realized how powerful this algorithm is. For all of a sudden, you have the Nerf level of fidelity, but real-time rendering. That's like something that we've never seen before. So from day one, when 3DGS got a paper out, we were like, okay, this might be the new future. Imagine a new team comes to you and says, Michael, we want to build the next big thing in radiance fields. What should we focus on?
One of the things I think is really interesting and isn't necessarily been explored yet is starting to actually pair these radiance field representations with traditional AI. When I say this, I mean like you can actually talk to a LLM about the data contained inside of a radiance field. So if we go back to the construction industry, for instance, and we want to say like, where are the steel beams on this construction site? And having a LLM go and take you to that actual thing, or count them for you, or tell you something about it, or evaluate like the pace of the construction schedule versus what it sees in the actual reconstruction, or start to say like, okay, maybe we should actually take this crane, which is over here, but according to the schedule, you'll be wanting it to be in this position. So I think that there's a tremendous amount of AI applications for this technology that have just not been explored at all. Because while we have, you know, a good precedent of photography as a way to like interact with and document the world, you know, we don't only look at photographs. We're able to extract a lot more information from them than that. And so I think it's really nicely timed with the rise of LLMs, and also, as you were mentioning, like the diffusion models too. So I think that there's an immense amount of applications that have just not, or potentially being developed in private right now, that have not made their way to the public world.
5 or 10 years from now, if people mention radiancefield.com in one sentence, what do you hope they'll say?
I would be very grateful if I play like a small role in the advancement of imaging from 2D into 3D within 10 years. I think it's very likely, you know, we will have already experienced this shift where the content that we enjoy is natively in 3D, and the way that we document the world around us is also done in 3D or dynamic 3D. It's my hope that I could contribute to that in some capacity across industries.